morning everyone. Today I'm here with the topic electrochemical cells. Here, electro means electric energy and chemical means chemical energy. It's a device in which chemical energy of redox reaction is converted into electric energy. Here, I use the word redox reaction. Now question arises, what is redox reaction? Redox can be converted into two parts, red plus ox. Red denoted for reduction, ox denoted for oxidation. Gain of electron is known as reduction and loss of electron is known as oxidation. A chemical reaction in which electrons are lost by one substance and gained by another is called redox reaction. In redox reaction, transfer of electron takes place which generate electric current. In this picture, there are two containers in which each container called half cell. The combinations in which an electrode is dipped into the solution of its own salt is called half cell. In a half cell, either a reduction or an oxidation reaction occurs. In one container, zinc rod is dipped in zinc sulfate, and in another container, copper rod is dipped in copper sulfate of 1 meter each. Here, as you can see, there is a salt bridge, which is U-shaped glass tube containing electrolyte KCl in agar-agar solution. Function of salt bridges: it completes the circuit and maintains electric neutrality. Let's move to the next question, that is difference between electrochemical cell and electrolytic cell. An electrochemical cell is a system that can produce electrical energy through spontaneous chemical reactions. An electrolytic cell is a type of electrochemical cell where electrical energy can be used to create a chemical reaction. Second difference is chemical energy is converted into electric energy in the electrochemical cell, and electrical energy is converted into chemical energy in electrolytic cell. Third difference is electrochemical cell don't need external chemical energy sources, but electrolytic cell need external electrical energy sources. In electrochemical cell, spontaneous chemical reaction takes place, and in electrolytic cell, non-spontaneous chemical reaction takes place. In electrochemical cell, anode is negative and cathode is positive, and in electrolytic cell, anode is positive and cathode is negative. These were the differences between electrochemical cell and electrolytic cell. Thank you. I hope you enjoyed my video.
Good afternoon everyone. Today I will tell you about the ideal gas and non-ideal gas. Ideal gas. Ideal gas is that in which there is no attraction between the molecules and it doesn't interact with each other. Non-ideal gas is that in which there is attraction between the molecules and interact with each other. In ideal gas, it obeys the Rayleigh law and all the temperature and concentrations. In non-ideal gas, it doesn't obey the Rayleigh laws and all the temperature and concentration. In ideal gas, the components can be separated by distillation, and in non-ideal gas, the components cannot be separated by the distillation.
Good morning to one and all. I'm Janvi, and today I'm here to explain about my topic, which is Rolle's law. Very firstly, I want to give a note, which is that Rolle's law is only valid for volatile liquid. We will learn about in our limitations also. So Rawls law, it is what does it state? It states that for a solution of a volatile liquid, partial pressure of each component in a solution is directly proportional to its mole friction. Means for each component in a solution, it is directly proportional to its mole fraction. And for example, in a solution, there are two components, component A and component B. In component A, we have taken partial pressure of A, which is directly proportional to mole fraction of A. And when we will remove the sign of proportionality, we will get pure vapor pressure of A. We will get this, and we will put it over here, and we will get this. And then what about component B? Suppose in this also we will do the same. Partial pressure of B is directly proportional to mole fraction of B, and when we will remove the sign of proportionality, we will get our answer. And these two are very important formula for our numericals also. Now according to the Dalton law of proportional Dalton law of partial pressure, P total equals to partial pressure of A plus partial pressure of B, which means and here we will value, here we'll put the value of it. Partial pressure mole, which is pure vapor pressure, of mole fraction of A, and pure vapor pressure of B n with mole fraction of B, and then we will get our answer, which is PS, which is partial pressure. This is according to your Dalton law only. So and there is one more question for proving, which may come in, which many times come in a competitive, not in boards exam, not in competitive. Prove that P total is equals to pure vapor of P plus pure vapor of A minus pure vapor of P into mole fraction of A. So solution is here. First of all, we will put the value of pressure A and pressure B. And here we have put in the value. Then according to Dalton law, we will solve it in this way. And here we have and we know that pt equals to pa plus pb, and we have put in the value of it in it, as we know that mole fraction of p equals to 1 minus mole fraction of a, and we will put the value of it here, and then we will calculate it, and at last we will get our answer that that pure vapor of pure vapor of b, we will get this over here in last, and like this we will prove it. Now we have some limitation of Rawls law. So first is that this law is applicable for this only, this law is applicable for the applicable for volatile liquid. Second, this law is applicable to ideal solution. This law is applicable to the solution whose heat of dilution does not change, and it is applicable to the solution whose total volume is equal to the sum of the volume of the solution and solvent if they are in liquid state. It is applicable to the solution. It is applicable to that solution whose total volume is equal to the sum of the volume of the solute and solvent if they are in liquid state, not in any other state but only in liquid state. Fifth limitation is this law is applicable to non-electrolyte aqueous solution. This law is applicable to non-electrolyte aqueous solution which do not undergo any dissolutions and dissolution when solute is dissolved in solvent. That's all about my topic. Thank you and have a nice day ahead.